Hello, Hamza. Hello. Hamza, are you listening me? Hello, Hamza. Hamza, is my voice okay? Hamza, hello. Hamza, if your microphone is not working, then you can write in the chat box. Okay, so today we will start the geometrical optics. Okay, this is geometrical optics is also known as ray optics. So what is optics? Basically, optics is basically the study of the light. Okay, the branch of the physics which deals with the study of the light. And now, what is light? Light is that part of electromagnetic spectrum which helps us to see various objects. Okay, so light helps us to see various objects, and this is that part of electromagnetic spectrum, visible portion of electromagnetic spectrum. So in electromagnetic spectrum, we have seen that we have gamma rays, X rays, ultraviolet, and visible region. infrared, microwave, and radio wave. So in visible region, we have this vibgyor, violet, indigo, blue, green, yellow, orange, and red. So this visible region is responsible for the with the help of this visible region uh, of the electromagnetic wave, we are able to see the object. Okay, that is why this is known as the visible region. So the wavelength of this visible region is approximately 400 angstrom to 7600 angstrom. Okay, and the last class I have told you that when you are moving from gamma rays to the radio waves, so wavelength is increasing. Okay, so this wavelength range we can see. Okay, for this wavelength range we can see the object. Okay, so wavelength is represented by lambda. So here lambda is increasing. Okay, from gamma rays to radio wave, lambda is increasing. So basically optics is divided into two parts: ray optics, and this is known as also known as the geometrical optics, and wave optics. So basically in the ray optics we will study the reflection and refraction. Basically reflection and refraction are the phenomena in which the object that are involved, like the mirror, like the lenses, like the prism. First we will study mirror, and from the mirror we will study the reflection of light. After that, lenses. So lenses, refraction of light. Prism, again the refraction of light. Okay, and dispersion of light from the prism. So basically in case of the optics, in case of the ray optics, basically the dimension of the object are much bigger than the wavelength of the light. So basically you can see the dimension of the object, mirror, lenses, prism, much bigger, okay, as compared to the wavelength of the light. Now wave optics. In case of the wave optics, we have dimension of the object. Like in wave optics, when we will study wave optics, so there we will see there will be slits, light will pass through a very narrow slits, holes, and there's the size of these slits or hole are comparable to the wavelength of the light. Okay, are comparable to the wavelength of the light. So here we will study the reflection and the refraction, and here in wave optics we will study interference, diffraction, and polarization. So basically in ray optics we will study mostly reflection and the refraction. So there are some points that you should know before study of the ray optics. First is light always travel in a straight line. After that, the path of the light is called ray. The path of the light. So basically, this is a ray, and this ray is showing the path of the light. Okay, this ray is showing the path of the light. Okay, if I am suppose saying the ray is going in this direction, so means light is going in this direction. So basically this is the ray, and this ray is defining that the light is going in this direction. Okay, now if you combine a number of rays, if you combine a number of rays of light, that will be known as the beam of the light. That will be known as the beam of the light. Okay, that will be known as the beam of light. So beam of light. So a bundle of rays is known as the beam of light. Okay, a bundle of rays is known as the beam of light. So this is the introduction part. Okay, this is the introduction part. So at least these things you should remember, you should know. And after that we will discuss laws of reflection. So Hamza, can you tell me what are the laws of reflection? In 10th class you have studied. Very simple laws of reflection. Can you tell me laws of reflection? Okay, so Hamza, are you there in the meeting? You can write in the chat. Hello, Hamza. Please write in the chat box. Okay, so basically laws of reflection, when the reflection is taking place and that reflection is taking place in accordance with some of the laws. Okay, so for example, here this is the surface. Okay, this is any surface. Here I have taken a plane surface. Okay, this is a plane surface I have taken. So plane surface I have taken. Hmm. Okay, so this is the plane surface basically. Hamza, are you there in the meeting or not?
Yes, sir.
Okay, so understanding now what I am saying. This is a plane surface. So basically, a light ray. This is a light ray. This is the incident ray. This is the incident ray. Okay, and this incident ray, and here is not. This is the normal. Okay, so this normal is basically making an angle of 90 degree with the surface. This is a surface, and this is the reflected ray. So means here reflection is taking place. Reflection of light. Okay, and this is a normal, and this is a this angle is angle of incidence, this angle is angle of reflection, you know, already these things. So basically laws of reflection, there are two laws of reflection. Number one is laws of reflection. Number one is the angle of incidence is always equal to the angle of reflection. This I is always equal to R. Suppose this I is 30 degree, then R will also be 30 degree. Suppose I is 60 degree, this R will automatically will be 60 degree. This is always valid. And another law is the incident ray, this ray, and reflected ray, this ray, normal, this normal, lie in a same plane at the point of incidence. Okay, so basically this whole phenomena of reflection is taking place in a plane. Okay, what is the meaning of the plane? Okay, I am explaining what is the meaning of the plane. So plane means okay, this is just a, you can just consider this as a plane, this as a plane. Okay, here is incident ray, here is normal, here is the reflected ray. Okay, so all of the things here taking place, this reflection phenomena is taking place in a plane. So basically plane, you can also imagine, uh, the screen of your laptop is a plane. So this diagram we have drawn on the screen of your laptop. So basically this incident ray, reflected ray, normal, all are lying on the screen of your laptop, means you can say the incident ray, reflected ray, normal at the point of incidence. This is the point of incidence where the incident ray strike is known as the point of incidence. Okay, so the incident ray, reflected ray, normal in a normal lie in a same plane at the point of incidence. Okay, so basically this is the point of incidence, point of incidence. Two laws are there, first, second, and these laws are always valid. Means for plane surface these laws are valid. Okay, for the spherical surfaces that we will discuss, concave and convex lens, for those surfaces also these laws are valid. Okay, now talking about the spherical surface, so this is a sphere. Okay, this is a sphere, and this sphere is polished from the inside. From the inside this sphere is polished. So basically this is the incident ray. What ray? This is the incident ray. This is the incident ray, and this is a point of incident. Now what will happen here, in this case, mm, we have to draw the normal. So basically normal will pass from the center always. Normal will pass from the center. So basically if this is the angle of incident I, then there will be the angle of refraction also. There will be the angle of refraction also means this light is striking this surface here. Okay, so this is a normal and this is the angle of incidence. Now reflection will take place. So reflection will take place according to the angle of, so suppose this is the this is the reflected ray, and this is the angle of reflection, this is the r. Here your I is equal to r. Okay, this is basically the reflected ray, this is the reflected ray. Okay, so remember this point, normal passes through center of, normal passes through center of sphere. Okay, so this is basically the normal, n is the normal. If there is a spherical surface, then normal will always pass through the center of that sphere. Okay, okay Hamza. These are the basic concept from the 10th class. You can see this till here 10th class is there. This spherical surface is new, I think, for you. Okay, and after that we have the spherical mirrors. We have spherical mirrors. What is the meaning of the spherical mirrors? The mirrors which are made from the sphere is spherical mirrors. Okay, spherical mirrors. So this is a plane mirror, this is a plane mirror, and this concave and convex are the spherical mirror. So basically this is a concave mirror and this is a convex mirror. So we will see how the concave and convex mirror are formed. Basically this concave and convex mirror are spherical mirrors. Basically this is plane mirror and this is spherical mirrors. These are spherical mirrors. Okay, this is also a spherical mirror, this is also a spherical mirror. Okay, so how the this mirror is formed? Suppose this is the sphere, this is the sphere, and this C is the center of the sphere. Now you have polished this. Okay, what you have done, you have polished this. Okay, you have polished this surface. What is this? This is a polishing, polished from this side, and after that you have cutted this part. Okay, after that you have cutted this part like this. Okay, you have cutted this part, and this cutted part, the part that you have cutted is this now. Okay, the part you have cutted is this now. Okay, so basically this is a concave mirror, this is a concave mirror you have. So now you understood now how the concave mirror is formed. Now we can take one example, how the convex mirror will form. This is a concave mirror, this is looking like a cave. Okay, this is a concave mirror, this is the, here this is the reflecting surface. Okay, this is the reflecting surface. Here this is the reflecting surface. Basically this is the concave mirror, I think you already know, and this is a center. Okay, this will be the center if you will complete this like this. Okay, so basically this mirror is a part of the sphere, so this is the center of the concave mirror. Okay, and this R is the, and here is another point, here is another point, pole. This point is the center of the sphere, pole. Pole is the center of the mirror. Center, not the center of the sphere, center of the mirror is pole. Okay, and line joining the center and the pole is known as the principal axis. Okay, so basically this line is the principal axis, CP is the principal axis. Okay, So this CP is basically what? Principal axis. CP is principal axis. Okay. And what kind of mirror is this? Concave mirror. C is the center of curvature. R is the radius of curvature. So CP line is the principal axis. Okay. And R is the radius of curvature, means this distance you will say. This distance will be the radius of curvature R. After that, suppose if you want to make a convex mirror, so what you will do? You will just polish like this on the sphere. You can take another sphere also, and you will cut this part of the sphere. You will cut this part of the sphere like this. Okay. When you will cut this part of the sphere, you will get this mirror as a concave mirror, convex mirror. Okay. This mirror will be the con. Okay. So basically this here, this is the reflecting surface. Okay. This surface is the reflecting surface. So this surface is the concave reflecting surface. Concave reflecting surface. That is why this is known as the concave mirror. And here this is the convex. Hamza, is your internet okay? Hello, Hamza. Is your internet okay?
Recording.
Okay, you can write in the chat box if I am asking something. Okay. Basically, pole is represented by P. Pole is represented by P. Principal axis, line joining the center of curvature and the pole. Okay. Line joining the center of curvature and the pole. And what is the aperture? Aperture is basically that part of the mirror, from up to which the light can fall. Okay. Suppose this is a mirror, so this portion of the mirror will be the aperture. So we can show aperture like this. Okay. So this whole portion will be the aperture. Okay. Whole portion will be aperture. So really this is the mirror and this is the aperture. Okay. So these are the spherical mirrors. Spherical mirrors are of two types. First is concave. Another is convex. First is concave, another is convex. First is concave, another is convex. Okay, Hamza? And this is a plane mirror. Okay, so this is finished now. After that, we will discuss focus. Okay, after that, we will discuss focus. So suppose this is what type of mirror is this, Hamza? Can you tell me? Hamza, can you tell me what type of mirror is this? You can write in the chat box. Fast, tell me fast. Beta, this is a concave mirror. Here also it is written that concave mirror. Okay. So now this is a concave mirror. This is a concave
That's what
mirror.
I'm saying, sir.
Huh? You are also saying your voice is not coming to me actually. What is happening? Is your internet okay? Okay, so focus on the screen. Basically, this is a concave mirror and this is the polished.
What's it?
Hmm? Hamza, your voice
Proceed.
is cracking.
Sir, I cannot hear you. Can you say again?
Am I audible? Now am I audible? Please check your internet, Hamza. I think your internet is not okay. My internet is okay. Check your internet, please. Hamza, please. I have just written something in the chat box. Okay. Hello, Hamza. Okay, so this is a concave mirror. Okay, this is the center of curvature of the concave mirror. This is the uh, focus. Okay, this is the focus. We will take it later. Okay, so basically here what will happen? Uh, this point is the pole. Okay, center of the mirror. Okay, this point is the center of the mirror. So this ray is parallel. Okay, this ray is parallel. So this ray will go like this. Okay, this ray will go like this. Hello, Hamza, are you there?
Yes, sir, I'm there.
So, are you getting what I am saying?
Yes, sir.
Okay, now listen. This is very important point. This is very important point. See, this is the first ray. This is the first ray of light, and this is a concave mirror. Okay, this is a concave mirror. Okay, so this is the first ray of light, and this first ray of light is parallel to this principal axis. Basically, this is the principal axis. This is the principal axis. This is the center of curvature. This is the pole, and this is the first ray of light. Okay, so as this is a spherical mirror, so this is the incident light. Okay, this is the incident light. So can I draw the normal for it? Can I draw the normal for it? So normal for it will be like this. Okay, so normal for it will be like this. Okay, so this for this light, the normal I have told you for the spherical, when you will complete it na, so it will become a sphere na, when you will complete it. So for the sphere, the normal always passes from the center. So this is a normal. Okay, so this is the angle of incidence I. Okay, so accordingly there will be the reflection of the light. So basically there will be the light ray like this. Okay, reflection will be like this. So basically this will be the angle. Okay, you can suppose this angle as theta. Okay, this angle is theta, so this angle will also be theta because angle of incidence is equal to angle of reflection. Same is the case for this ray. This ray will also pass like this. Okay, so this ray will also pass like this. So both rays will meet at a point, and this point is known as the focus F. Okay, so basically F is known as the focus. What is F? F is known as the focus of the concave mirror. Of the concave mirror. So you can write the definition, okay, of focus. Okay, now see here. For the concave mirror, rays of light parallel to the principal axis. So these are the rays of light parallel to the principal axis after reflection. So here the reflection is taking place, here reflection is taking place. After reflection, meet at a common point. Meet at a common point on principal axis called focus. Okay, called focus. And can you tell me these rays are actually meeting or just appearing to meet? These rays are actually meeting or appear to meeting? Hamza, can you tell me? These rays are actually meeting. Okay. So rays are actually meeting. Meeting. So you can say concave mirror have the real focus. Concave mirror have the real focus. Okay. After that, we will define the focus for the convex mirror. For the convex mirror, we will define the focus. We will define the focus for the. This is a convex mirror. Okay. Second is this is convex mirror. So convex mirror is basically reflecting surface is the bulging outward surface. So basically these are the parallel rays. Parallel rays means rays parallel to the principal axis. Okay, rays parallel to the principal axis. So basically what will happen? First we will draw the normal. I have told you as this is a spherical surface, so normal will pass from the center of curvature. Sorry, not from here. Normal will pass like this. This will be the normal. Okay, this will be the normal. So what will happen here? In this case, this ray of light, the reflection will take place like this. Basically, this is suppose theta. Okay, this is suppose theta, and this is the normal. So what happened? Reflection will take place according to the angle of incidence. There will be the angle of reflection. Okay, so from here, suppose this ray is reflected like this. Okay, this ray is reflected like this, and when you just extend this ray in the backward direction, so you will get this will this ray will cross this. Okay, like this. Okay, now same is the case for this ray. So this is the ray, this is the incident ray, and falls on this surface. Reflection will takes place. Okay, so reflection will takes place like this. So basically you can say that I am just modifying it. Okay, basically you can say that Okay. If you want to draw the normal for this, then you can draw the normal for this also. Okay, normal, basically this is n dash, another normal. So basically now this is the ray of light, and at this point the reflection is taking place. This angle is also theta. This angle will be theta. Okay. So here ray of light is this, reflection is taking place. After reflection, the ray is going in this direction, and here the ray of light is coming parallel to the principal axis, and reflection is taking place. The ray of light is going in actual in this direction. Okay. Now when you will produce these reflected rays in the backward direction, so these rays will meet at a common point. These rays will meet at a common point, and this common point is known as the focus. Okay, this common point is known as the focus basically. So basically this F will be the focus. This is the focus. So F is focus here. So F is the focus. So basically parallel rays parallel to the principal axis. So these are the rays parallel to the principal axis. Basically this is the principal axis. Rays parallel to the principal axis. After reflection, this is after reflection diverges. So these rays are diverging after reflection. The divergent rays on being produced in a backward. So when you will produce these rays in a backward direction, meet at a common point called the focus. Okay. Now, can you tell me this convex mirror have a virtual or a real focus? Hamza, can you tell me these rays are actually meeting or just appearing to meeting at this point? Hmm? These rays are appear to meet. Okay. So rays
They are
are,
not.
they are not meeting actually. They are not meeting actually. They are just appearing to meet at this point. Okay. So you can write rays are appearing to meet. Appearing to meet. So rays are appearing to meet. So this will have a imaginary focus, or you can say virtual focus. Virtual focus. So basically a convex mirror have the virtual focus. Okay. Okay. Now after this there is a focal plane. Focal plane. Now what is focal plane? This is a concave mirror. This is a concave mirror, and basically this is the principal axis. Okay. This is the principal axis we know now. Somewhere here will be the center of curvature. This is a, and these parallel rays are striking on this concave mirror. Now what will happen? These parallel rays, will meet at a point. These parallel rays after reflection will meet at a point. Suppose here these rays are meeting at this point. Okay. So reflection is taking place. Here is reflection. Okay. Reflection is taking place after these rays are meeting at this point. Okay. So this point always be, this point will be always be on the focal plane. This point will always be on the focal plane. Okay. So this point will always lie on the focal plane. What is this? This is the focal plane. Okay. And somewhere here will be focus. So basically the definition of focal plane you can write set of parallel rays. So set of parallel rays, two rays are there. After reflection from the concave mirror meet at a point. So after reflection meet at a point. So this is a point where the rays are meeting. These points always lie in a plane called the focal plane. Basically this plane is the focal plane. Okay. Now this is the focal plane we have defined for the concave mirror. Now we will define the focal plane for the convex mirror. But there can be another case also. There can be another case also you can take. I want to show you one more case. Okay. So one more case I want to show you, and for that there is a requirement of this lens, I think. Okay. This is a pole, and basically this is a principal axis. Okay, this is a principal axis, and now this is the center of curvature. If the rays of light are like this, if the rays of light are like this, suppose rays of light are like this, first ray is this, another ray is this. Okay, so these rays will meet at focus, we know, will meet at a common point called focus. So we can just say that these rays will, this focus point will be also, you can say, on the focal plane. Basically this is also a focal plane. So in this way also focal plane is there. Okay, basically parallel rays always meet at focal plane. Okay, at a common point called focal plane. Now for the concave mirror, second, for the concave mirror, for the convex mirror, convex mirror. Oh, this is a this is completed, I think. Now for a convex mirror, this is a focal plane for concave mirror. Now we will define the concave focus for the focal plane for the convex mirror. Okay, for the convex mirror we will define. So very simple. Again, what we will do. This is the first ray of light. Okay, this is the first ray of light. What will happen? Reflection will take place. This ray will reflect like this. Okay, and when you will produce this ray in this direction, backward direction like this. So first do the refraction. Just a minute. So these are the ray diagram. It is always better to draw the ray diagram on the board, or so basically this is the reflection taking place of this ray. Now of this ray, the reflection is taking place, suppose like this. Okay, like this. And now what you will do, you will produce these rays in backward direction. This is the reflection of this another ray. Basically these reflected this ray is reflecting ray, this is a reflected ray. Both rays are diverging in nature, but what I am doing, I am just producing these rays in the backward direction, here or So finally these rays are meeting here when we are producing these rays in the backward direction. Okay, so meeting here. Okay, at this point these rays are meeting. So this point these rays are meeting. So basically this point will lie on the focal plane. Okay, this point will lie on the focal plane. Basically this is your principal axis, and here will be somewhere will be your pole. Understood, Hamza? So whenever there will be the parallel rays, because you can see here these are the incident rays. These are the incident rays. So these are parallel incident rays. So you can just set off parallel rays after reflection diverges. So these are the parallel rays. Initially these are the parallel rays. So after reflection, these rays are getting diverged, and those divergent rays on being produced backward. So when you will produce these divergent rays in the backward direction, they will meet at a common point, and these points lie on the focal plane. So basically what is this? This is a focal plane. This is the focal plane. After this, there is a sign convention. Sign convention first is all distances are measured from the pole. So this is a pole. All the distances you will measure from the pole. First sign convention. Okay. All the distances you will measure from the pole. Another, the direction of the incident ray is taken as positive. The direction of the incident ray is taken as positive, and any distance measured along incident ray is positive, and measured opposite to it is negative. So remember this point. Okay, for example, this is the focus, and if I am saying that this is the incident ray. Which ray? Incident ray. Incident. This is the incident ray, and direction of the incident ray is this. So now for this length, if I want to measure this distance, suppose if I am measuring this distance I am measuring. What will be this distance? Basically, this distance is basically the suppose this distance is, have we completed the focal length? Just a minute. Okay, I have not told you na focal length. Okay, so we will discuss later. Basically, if I am measuring, suppose this distance is basically the focal length. Okay, small f. Small f is the focal length. Focal length. So for measuring focal length, you will measure the distance from the pole. Means you will measure the distance in this direction. So direction of the incident ray is this, but you are measuring the distance in this direction. So this focal length f will become negative. F will become negative. Okay. In case of the convex lens, suppose this is the incident ray. Incident ray is this, and suppose this is focus, and you are measuring this distance. You are measuring this distance, and always you will measure the distance from the pole to focus, from the pole. So this, suppose this is the focal length f. So you are measuring the distance. This is the direction of the incident ray. Okay, this is the incident ray. Incident ray, and you are measuring the distance in the direction of the incident ray, so the f distance will be positive. Okay, f distance will be positive. Now height above the principal axis is positive and below the principal axis is negative. So this is the principal axis. This is the principal axis. So this distance will be positive, this distance will be negative. So remember all these points. Okay. Okay, Hamza, now please take the screenshots. Hamza, please take the screenshots.
Yes, sir. Done.
Done. Okay, just you can tell me when completed. Okay. Oh, just a minute. Now take the screenshot. Completed, Hamza?
Done.
Okay. Done this. Do this. Completed?
Yes.
Okay. When completed, you can just tell me, sir, I have completed. Okay. Now take the screenshot of this. Completed? Done? Hamza, done? Now take this in screenshot. Done? Completed, Hamza? Hamza, hello.
Yes, sir.
Completed? Please tell me now
Yes.
when completed. Otherwise, how will I know you have completed or not? Okay, so just a minute. Now take the screenshot of this fast. Com- Completed? Completed, Hamza? Your voice is not clear. So if completed, na, so you can write in the chat box just D, small d. You can write in the chat box.
Yes, sir.
Okay, you should write a small d in the chat box, so I will understand. I should scroll down. Okay,
Sir, done.
done. Okay, so now take this screenshot fast.
Done.
Okay, so okay, so do this fast. Done. Done.
Done.
Now take this screenshot fast.
Done.
Take this.
Sir, 1 minute.
Okay.
Done.
Done. Okay. Completed. Okay, so after this, now one topic I will discuss here, that is focal length. I have not discussed what is focal length, so you should know what is focal length. Focal length. This focal length is represented by small f. Okay, so what is focal length? Basically, the distance between the pole and the focus is the focal length. Okay, so just a minute. Basically, what happened? Just wait. This is not working. Why this is not working? Hmm. This is the principal axis. Okay, and this is a focus. Okay, and here somewhere will be the center of curvature. So basically, focal length is the distance. Focal length is the distance from pole to pole to focus. Basically, what distance I am talking about? I am talking about this distance. This distance I am talking. Okay, so this distance is a small f, focal length. This distance, and this focal length, for example, suppose a ray of light is like this. A ray of light is suppose like this. Okay, so what you have to do? You will draw the first. You will draw the normal. What happened? Just wait. Suppose a ray of light parallel to the principal axis is there. A ray of light parallel to the principal axis is there. This is the ray of light parallel to the principal axis is there. So after striking from the mirror, reflection will take place. So for that we will draw a normal. So normal to the mirror will always pass from the center of the curvature. Okay, normal to the mirror will pass from the center of curvature. So this is the center of curvature C, and this is basically normal. If this angle suppose is theta, I am not driving this now. If this angle is theta, and what is this? This is the incident ray. This is the incident, and accordingly there will be the reflection also. Okay, so we know that after the reflection, this ray will pass from the focus. This ray will pass from the focus like this. Okay, parallel ray always passes from the focus. We will discuss this also. This will be also theta because angle of incidence is equal to angle of reflection. So if this is a case, then you can say that the focal length of the mirror is given by r minus r by 2 sec theta. This is the formula for the focal length. Okay, this is the formula for the focal length. So this is the formula for the focal length. But what happens now? What happens if mirror have very small aperture? Basically, in our syllabus, we will study small aperture mirrors. Okay, very small aperture. We will get 90% of the time. Then rays will be paraxial. Will be paraaxial. Okay, the rays will be paraxial. So you can say that you can say that this theta is very small. Theta is very small. So if theta is very small, then you can say your sine theta can be written as theta. Okay, Hamza. So no problem. That is, you are right. Website for the homework is showing error. That is opening it, not here. So beta, first take the class. Then after the class we can discuss this. First understand this what I am teaching. That you can check after the class also.
Yes, sir,
Okay.
but to ask tell you that, so I told.
Okay, no problem. I will just convey this message to the company. Okay, no problem. So if this theta is very small, what theta? If this theta is very small, then sine theta can be written as theta and cos theta can be written as 1. because theta is small means you can say theta is tending to 0. Theta is tending to 0. And you can also write cos theta is 1 upon sec theta. You know that cos theta is 1 upon sec theta. If cos theta is equal to 0, then you can write sec theta can also be written as 1. So this formula will change. Formula of the focal length will be r minus r by 2 into 1. So the formula of the focal length will become r by 2 only. So basically 90% of the time, 90% of the time this formula will be valid. So remember, focal length is equal to half of the radius of curvature. Okay, focal length is half of the radius of curvature. So remember this. Okay, what I done? Okay, no problem. So this is the focal length. This is focus. Okay. After that, we have focal plane. After that, the focal length. So basically, this topic should be here. Just wait. This focal length topic should be. We can just discuss this here. Okay. So have you taken the screenshots of these? These you have taken. This also you have taken. This also you have taken. This also you have taken. This I think also have taken. Now take for the screenshot for the focal length. This is very important. Very focal length is very important. Okay, I'm gonna take the screenshot fast. Completed. Hamza, done. Hamza taken screenshots. The what are you doing? Hello, Hamza. Okay, done. Very good. Now complete this. Complete this. Should I move to the next topic? Okay. Sign convention we have completed. Okay, now take the screenshot fast. Okay, so that is why that this distance between the focus and the pole is known as the focal length. Okay, distance between the pole and the focus is known as the focal length. Now it will be clear. Done, Hamza?
Yes, sir. Done.
Okay, so finally do this Then we will move to the next topic. Basically, some of the topics means we just today's lecture will be 90% from the 10th class. 10th class light chapter light from the 10th class. Okay. So next topic is rules for the image formation for the concave mirror. So what happen when the ray of light will pass from the concave mirror? So basically this is a concave mirror. Which mirror is this? This is a concave mirror. This is a concave mirror, no? This is a pole, this is the focus, and somewhere here will be the center of the curvature. And this ray of light is parallel to the principal axis. If this ray of light is parallel to the principal axis, so it will always pass from the focus. It will always pass from the focus. So first rule is this. Second, if a ray of light is this is a ray of light. If a ray of light is passing from the focus of the concave mirror, then it will become parallel to the principal axis. It will become parallel to the principal axis after reflection. Okay. Third is when a ray of light is passing from the center of curvature. When a ray of light is passing from the center of curvature of the concave mirror, it will retraces its path after reflection. It will retraces its path after reflection. Why? Reason I am telling. If you will draw a normal, basically, if you will draw normal here, so normal will be like this. Okay, normal will also be like this. This will be the normal. So here, angle of incidence. If we are talking about angle of incidence is equal to 0. So angle of refraction should also be 0, na? So that is why it will retrace its path. Okay. This is this rule. A ray of light is falling at the pole. Falling at the pole. So now this is the center of curvature. So if you will draw the normal, so this line, this principal axis, this is the principal axis. This principal axis will work as a normal. Okay. So angle of refraction, suppose angle of incidence is theta. So accordingly, this ray of light will go in this direction like this. So this angle will also be theta. Okay. So if a ray of light falling on the striking on the pole, so after reflection it will make the same angle. It will make the same angle with the principal axis. Okay. So basically this is the principal axis. Okay. So note down. Please take the screenshot. Hamza, done? Completed, Hamza? Please take the screenshots. Okay, just take the screenshot of this fast.
Done.
Done. Okay, last rule. All these rules will be used. All these rules will be used for the image formation of the concave mirror. Okay, all these rules will be used when we will study the concave mirror, image formation by the concave. Now, image formation by the concave mirror. Okay, so basically, this is a concave mirror. Which mirror is this? Concave mirror. This is a concave mirror. Concave mirror, and this is the object. Okay, what is this? This is the object. Okay, suppose from this object, suppose this object is known as a, this is B and this is A. So AB is the object. Okay, so now we want to find in this is the concave mirror, and in front of the concave mirror, beyond the center of curvature, an object is placed. Okay, so image formation by the concave mirror. So this is the case when the object is between infinity and the center of curvature, or you can say beyond C. So object, this is the object, and this object is beyond C. So how we will form the image? Okay, see, first ray of light is like this. Suppose, why this is not working? Just wait.
Sir, class is over.
No, no, no. We have time. Okay. After this two image formation, the class will be over. Why this is not working? Just a minute. Hamza. Now it's okay, I think. So basically, this is a so now see, this is the object, and basically we will just, this is the ray of light from this object. Okay, first ray of light from this object, and we know that whenever the ray of light is parallel to the principal axis, this ray after reflection will pass from the focus. Okay, so this ray of light will pass from the focus. Okay, and another ray from this object is passing from the focus like this, passing from the focus. Okay, and if a ray of light, you know, when passing from the focus becomes parallel to the principal axis, so somewhere here both the rays will meet. Okay, somewhere here both the rays will meet. Okay, so here these rays are meeting at this point. Okay, sorry, this point, at this point both the rays are meeting, and this is a point where the image is formed. So here the image will be formed. Okay, here this image will be formed. This is the image basically. Okay, so you can say this is A dash and this is B dash. Okay, this is A dash and this is B dash. So basically this is the image formed, Now you can see here the rays are actually meeting, so this image will be real. So basically A dash and B dash is what is the image, okay, and AB is what is the object. So here the rays are actually meeting, so you can say this image is a real. And see, this image is inverted also, okay, this is the direction of the object is like this, so image is like this. So basically for the image you can write image is formed between center of curvature and focus. Now you can see this is the focus and this is the center of curvature, so image is formed between the center of curvature and focus. Real and inverted, okay, real and inverted. Diminished, so you can see size of the object is greater than the size of the image. Now there is one more term, magnification. So basically magnification is represented by m. It is given by height of image divided by height of object. Now in this case the height of image is greater, height of image is less, height of image is less, and height of object is greater. But for the height of image is above the principal axis, so height of image you will take positive and height of object you will take negative. Okay, height of object you will take negative. So this term will be positive, this term will be negative here. So basically finally you will get negative. Okay, so magnification will be negative. Okay, and magnitude of the magnification, if you are talking about the magnitude of the magnification, height of image is less. Okay, here height of image is less than the height of the object, that is why magnitude of the magnification will be less than 1. Okay, so magnitude of the magnification will be less than 1. Okay Hamza, so remaining fifth 5 cases we will discuss in the next class. Okay, just take the screenshot fast. So that's how we form the image of an object, okay, in front of the concave mirror. Just fast, take the screenshot. Done. Hamza, completed.
1 minute.
Okay, okay.
Done.
Done. Okay, so these are the characteristics of the image, right? Note this also. And this mod of m, you know the magnitude of the magnification. Okay, remaining cases we will discuss from next class. Okay, so from here we will have the topic next class. Okay, so take the screenshot. Taken. So do you want to ask any doubt regarding this? If you want to ask any doubt regarding the ray diagram, basically this is the ray diagram. Okay, this is the ray diagram of the image formation. So if you want to ask any doubt, then you can ask me, no problem. This is basically
No, sir.
poll. Okay, so Hamza, we will meet in the next class. Okay, and before coming to
Okay,
the
sir.
next class, please revise your notes properly. Okay, so this